Okay, so we're starting up again with Talkaoke. If you want to come down on the table of chat, you're very welcome to and talk to a couple of our regulars. Maybe Rick, we need you. We need a bit of meat on the table at this point. What's that? Anyway, let me just take the credit for this conversation. So let's just see who we've got around the table. What's your name?
Rick.
And
Dave.
And
Fiddy.
And maybe this person here, maybe not. So the whole point of Talkaoke is that it's kind of up to you what you want to talk about. We have been. Can you remember what the theme is for today, for this particular moment? Because they have given us some themes, but we very, very loosely stuck to them. Yeah. Okay. So, but what
I'm guessing they're the experts in that theme. I don't know. I've closed them.
We'll find out.
About youth violence in Newham, then is that interesting?
Well, if you were there yesterday, but you can come. We've got a very busy week actually at the end of February where we're doing the Science Museum. We're doing a mental health gig in the morning. Then we're going to the Science Museum. And then the next day we're doing a studio session, and then the next day we're going to Natural History Museum.
I did for a year. I worked at the Royal London Hospital in the trauma team, and it was horrific. Some of the violence we had coming through Whitechapel and Newham, because we were the trauma centre. All the trauma came to the Royal London, and to treat patients who have been stabbed and are dying horribly is not a very.
This is all conjecture we could have done with yesterday, but today it's the question of what.
Let's talk about genomics.
What is it?
At 2 o'clock we were supposed to be talking about genomics in society. Who is genomics for? We kind of did, right? Yeah. And now it's of sequencing technology and providers.
Oh, we had the sequencers early. We had Ricky from Billericay, who's selling the Bio-Pacific 2 sequencer, which can do 20,000 base pairs.
Right. Anybody working for any sequencing companies? Agilent, what others? Illumina, Bio-Pacific, Precision Biosciences, Perkin-Elmer. I'm just rattling off companies that probably don't exist anymore, but just come over. Sequence. We want sequencers and sequence technology people, and all those kind of nanopore, Oxford nanopore. If you've got nanopore here, bring them over.
Okay, I've got a feeling that's not how the sequence is going to go. The sequence of events, but we'll see. We'll see. If we can bring people over.
CTTACGATT. See if that helps.
Should we be talking in base pairs just to get the people? Will that attract people over? If we just. Yeah.
So I did this thing in my daughter's primary school, where you
sequenced all their DNA.
No, I got them to look at the genetic code and how the DNA bases result in one-letter amino acids, and I got them to work out how to use DNA to write their name, and then they can't write their name, and they went up to the computer, tapped it in, and checked to the translation and see if it worked, and it was really great. And although they did come away thinking that all their cells have little letters in them, but it was good, and then we could start doing mutations and what happens.
So you went into a school trying to explain genetics, as you were saying earlier on that you wanted to happen in schools. You just went off and did it, and it's
letter of the alphabet. That's brilliant.
Yeah.
There's only 20 amino acids, so 6 letters obviously aren't represented. But then the advanced students went on to 2. They used two words. There was stop code on, and then another word. So they really got it. This was like when they were like 7, 8 years old, and they got it.
So this is kind of like primary school genetic Scrabble.
Exactly, and that's what they should be doing at primary school, not learning how to spell, because we've got spell checkers. They should be learning how to code DNA.
Okay, well, it's a kind of spelling in a way, isn't it? I mean, will children be revising for amino acid tests when they're like 9 years old rather than spelling tests? And will they be like, I can't get my, I don't know.
Look, I am a lecturer at Durham University, and I used to teach first year students about the genetic code and get them to kind of memorise the genetic code. They should have been doing this at primary school, not when they're 18, 19 years old and have got to university. This should be something that's straightforward. Everyone should know.
Yeah.
And that's if everyone start knowing that, then when they go to their doctors, then they know what they're talking about. So everyone needs to know about sequence. Everyone needs to know about DNA, amino acids, the whole lot. The basics.
So we've got a new face at the table. This is Talkaoke Freeform Talk Show. People just talk about anything here. There is supposed to be a theme. What was the theme again? Sequencing. Okay, yeah. But we are actually talking about that. We got Rick, we got David, we got Vinny. What's your name?
I'm Elizabeth.
And my name is Mikey. The moment was Dave has kind of suggested that we should be teaching kids about how DNA sequencing works when they're 8 or 9 years old. Instead of teaching them how to spell, they should have a basic understanding of how amino acids are compiled and doing stuff like that. Isn't that what you're saying?
Yeah. I don't think necessarily have to know the process of how a sequencer works because that's quite tricky.
Yeah.
But they should know.
Well, apparently it's got something to do with laser beams, I found out.
But the thing is, they should know that there's what DNA is roughly, that it's got a code and it's a relatively easy code to get their head round.
What age are you talking about?
Well, that's what I was saying. When I went to my daughter's class and they were 7 or 8, they got it. So I don't know, that kind of age.
So a 7 or 8 year old could understand it, and it should be. It's like reading, writing, arithmetics, genomics. We've got to come up with a word beginning with R, I suppose. Yeah.
I mean, I'm a A-level tutor, and I can tell you now, A-level students do not understand any of it.
Is it because they're too old?
No, I think it's just a lack of understanding on a basic level. But that's more their higher conscious knowledge. I think it's an age thing. I don't think you can teach people that age, 8 and 9, how a transcriptomics works. Like they will not understand.
Okay.
They don't.
Should we be teaching 9-year-olds? Let me bring in people, please, Dave. Otherwise, it's just going to be you talking to Vinny. So let me do my job. No, I know, but Elizabeth has come and joined in. I'm trying to get other people in to make it into a Talkaoke discussion. So please don't interrupt because we lost that person now. They've gone because I need to hit them with that question, which is, should we be teaching 8 or 9-year-olds about? Yeah, go and tell me what.
The last part of the brain to develop is the bit where it can adapt foreign concepts. 8 and 9-year-olds would not be able to understand that. They wouldn't. No, just flat out. I think. Don't get me wrong. If you teach them that ATT is stop and like the actual basics of triplets, then they might be able to comprehend that. But at the same time, they would not be able to get the whole protein translation, whole sequence thing. So I get where you're coming from, but at the same time, it's not really feasible.
You think you're sceptical, basically?
I'm very sceptical.
Okay, I mean, let's bring other people on this. What do you think?
Yeah, I think you could teach them the basics about codons and how the amino acid chains are formed, and it could be made into a game. My nephew loves games, so you could have different proteins. You type in the codon, you get one amino acid. You type in another, you get another amino acid, and you can build your own protein. So you want to make a protein, you can make a small.
Okay, so you could actually have a physical protein that you make with these little different. Yes,
and
it
then
could be a kind of.
You're learning without knowing you're learning, and we have to educate the public about DNA. At the moment, it's still a bit mysterious. It's still this thing that people do in laboratories, and it has no real practical application. But once the education comes through, once practicalities come through, then people will want to sequence their genome. They'll volunteer. I mean, they'll be queuing up to do it.
What do you think about this? Could turning into a game, would this work, and what would the game look like? Would it be a kind of, I think you're seeing kind of plastic kind of things that fit together or something like that.
I'm thinking of the ribosome, and as the DNA comes through, every 3 bases.
But would it be like a device, or would it be a computer game?
Yeah, be a computer game.
Okay, computer game. Okay, what do you think, Elizabeth?
I think it'd be more basic than that. You could literally say you need to make this protein, give them the table of the triplet codes for the amino acids, and then say go make it.
Yeah.
Because then you can get them to do the understanding of the degenerate nature of the triplets.
Okay, so you think a physical thing would actually be much better?
Yeah.
Teach them. Rick, what do you think about this? A DNA coding game? Would you play it?
Probably not, no.
Do you like board games and all that kind of stuff?
Yeah, but no.
I mean, what makes a really compelling board game?
Oh well, that depends on the person playing the board game.
When it's you playing the board game,
I don't know. I can't.
I'll come back to you on that one. I'll come back to you.
I mean, I did do this with the kids, you know, where they had to like write their names in the triplet code, and then they kind of got that idea, you know, of just that. And even if they don't understand anything about what it means or what it's stuff, they get an idea that there's a code that goes to another code, and then you can later on start, you know, putting in the ideas of mutations and, you know, that kind of stuff. And then I think if you just did it every year all the time, they would start to get it, yeah. Because I mean, the amount of time they spend doing spellings and things and arithmetic, which is totally useless for them. Do you know what I mean? Well, not totally. Well, just because you get an understanding of you said the concepts are hard, but at least it gives them a sort of starting to build up to some concepts that they can kind of get later on in life. That's what I think.
I mean, isn't like reading a kind of concept and books and stuff that spelling leads up to, so it kind of works in that sense, you know, how it's done now.
Learning how to spell words doesn't really help your reading, I don't think, that much. I think it's more just reading, you know, but maybe I'm wrong.
Okay. Should we be teaching primary school children about basic genetics, how it all works? Would it be useful, or would it just be like another abstract thing that kids have to do? I'll come to you in a second.
Yeah, I mean, when I was young, I had to learn Spanish, for example. I've never been to Spain, so that's been of no use whatsoever. But yes, I think in the future, genomics and genetics is going to be more important in medicine, and I think it'll be useful if later on they are genomed, as I hope everyone's genomed, then they'll be in much better position. We should educate the population as much as possible.
I just overheard someone say, "I don't know what this is." So that's me doing a very bad job. This is Talkaoke, where you're all welcome. It's a free-form conversation where we come up with stuff about really anything. Right now we're talking about, should we be teaching primary school children about how genes work, about the basics of genetic coding. Rather than teaching them spelling, they should know how a protein is formed and this kind of stuff. So this is what we're talking about. Come and join in. You don't have to, no commitment necessary. Give us your view on that. What do you think?
Yeah. I think you could create...
Let's find out what this person thinks. So we've got Elizabeth, we've got Vinny, we've got David, we've got Rick. What's your name?
Dan.
Dan, what do you think about this? Would that be useful? Would that help us enter this kind of era of genomics where people are a lot of what people have been saying is the public just don't get genomics. They've just not even got the first clue.
Well, if I look back to when I was a little kid and a scientist, and the kind of things that excited me were first being taught the quest for curiosity, which is a really fundamental part of scientific thinking, having a critical way of thinking towards scientific research. And also I think it's doing the experimental side, playing around with, you know, test tubes and, well, I don't know if you should be giving kids Bunsen burners, but certainly giving them the kind of basic tools and apparatus to play with. But alongside that, obviously you do need the basic understanding of biology. And I have to admit, I don't know what the curriculum is these days. It sounds like that if that's not in place, then perhaps we should be updating it. And certainly when I was at school, the things that were missing were the computational side of that. So now bioinformatics is probably such an important skill within biology. We should be thinking about giving people a basic understanding of the way that we analyse genes as we trend towards secondary school. That should certainly be working its way into the curriculum.
Okay.
So a bit of everything there, but I have to admit I'm not the best person to ask in terms of, because I know nothing about the curriculum at the moment.
Yeah, but I mean, have you got kids?
No.
No? Okay, yet to come. Yeah.
I mean, my daughter in primary school did learn about the gastrointestinal tract, you know, which is great, but she hasn't learned anything about genetics or genomics. So why is the gastrointestinal tract, which is quite an interesting concept, which is great that they're learning it, but why can they not also learn about genetics and genomics?
I mean, that does sound like a bit of an update, I suppose. Elizabeth, what do you think about all of this? Should some of this core science come in a bit earlier, and bioinformatics maybe at secondary school? and this, the basic concepts of genetics at primary school?
I mean, I think we're all going to be pretty biased in our opinion of what should be on the curriculum because this is the best topic in the world. But I think there is this coming into the curriculum now, like when I'm teaching kids, it is getting earlier and earlier of when these things are being installed, so I think that issue is being addressed, but at the same time there has to be taken into consideration the development that is going on, so it's kind of, if they could, the problem is even when you get to university level, some of the university teaching that I had only not too long ago is out of date now, so it's just always trying to keep the curriculum.
Can you give us an example? Of something that's
That put me proper on the spot then.
Something that's gone obsolete now.
Well, yeah, because I was going to pick a master's course that was based on karyotype analysis, but Krebs cycle, karyotype analysis is now going to be obsolete in the next. There isn't going to be karyotype analysis, and I was going to do a master's in it, and it's just like, well, that was going to be a waste of time. So I think the curriculum needs to be constantly updating.
I mean, is
more so than anything else.
Is learning just about learning relevant stuff, or isn't it? Because like Vinny learnt Spanish, but he's never been to Spain. And it's only £19 now on Ryanair. So I mean, surely you should at least try that out. But anyway, the point is it about learning for the sake of having relevant information, or is there more to it than that? Is learning just learning for its own sake, about expanding the mind? Does it matter if it...
No, education should be preparing the future generation for what is to come. And genomics is the future, really. Once we've got these great databases and we've tied them up to different diseases, we will be able to do far more with genetics. So it would be very useful if children could be taught at least the basics. I'm not saying they learn everything, but just what DNA is, and that they are 4 base pairs, and they can reproduce and they can create protein. That will be enough.
I mean, is there a danger that some of the things they learn might become obsolete?
That is a fundamental theory of genetics, so that won't change. I mean, sequencing, when I was at university we learned Sanger sequencing. Obviously we no longer use Sanger sequencing, we've got nanopores and all sorts of new technology. And same thing with karyotyping. In the past, if you wanted to see somebody with Down syndrome, you'd do a karyotype, trimosine 21, you'd see the 3rd chromosome. But obviously now you've got whole genome sequencing, you don't need to go to the karyotype. You don't physically need to see the chromosome to tell that there's an extra chromosome there.
Okay.
I mean, one of the issues though is the teachers. The teachers need to know this stuff really well. They need to understand it, and a lot of the teachers don't, because, like you say, they probably didn't learn it themselves very well at university. So, it takes a long time to get this into. They can't just sort of sometimes when things are imposed on the curriculum and the teachers don't get it, like this, then it kind of doesn't work.
Okay.
So I think it's if we're talking about how we should be building the education for the future, like I say, one of the core skills of science is all about the critical thinking element and that quest for curiosity. So what we should be thinking about these days in the age of Google, where literally you can Google anything you want and you will get an answer to that particular question. Is it right to be teaching people on a very fact-based learning course, or should we be pushing them more towards them understanding the skills to apply that knowledge within society? And should we be shaking up the way that we learn so that we're actually inspiring people to learn, as opposed to teaching them to learn for the sake of getting a job? The whole employment system will be vastly different in a decade's time because of the way that AI is changing society. The types of roles that we will need will be far more creative, focused in terms of the skills that those people will need to apply. So we should be building people educating people that are of that mindset, and genomics is no different to any other subject in that way.
I mean, we're all sitting here going on about how genomics is the future. Something else might supersede it in 10 years, but you guys will still all have jobs because you are good at solving problems, and you'll be able to talk about whatever the next thing is. And me too, because I'll just go to the next, whatever it will be, Genomics Festival or whatever. Anyway, Elizabeth.
But the education system as it stands is pretty messed up. Like the Victorians set up a system which just basically made workers to go in a factory. But he's right in saying that critical thinkers are more important these days because that's where the job market is going. But then on top of that, they're making kids make decisions earlier and earlier about what they should be focusing. So the way that it is now is you pick your A-levels when you finish your GCSEs.
But I mean, Elizabeth, can you imagine a world where everybody's critical? Like even the person's doing you a coffee, they're critically thinking about that coffee. Do we want that world where everyone's a critical thinker?
But if you get to people who are like dyslexic, education system's never going to best reflect what kind of thinker you are.
I mean, they could still easily have those critical faculties.
Exactly.
Yeah.
So a fact-based knowledge system is never going to be applicable for anything other than a factory job, which most of the jobs aren't going into these days.
Looking at history, the reason why Japan and Germany did so well after the Second World War was that their population was well educated and was forward-looking, and they were looking to the future. The factories they built were futuristic factories, and so that's the reason why those two countries, despite having been defeated and leveled to the ground, absolutely leveled, not a single building standing, they have now become the strongest economies in the world. And we have to educate our young people to the economy of the future.
Okay. Even though we don't know what it is?
Even though we don't know what it is. But we can have a rough estimate.
Can have a good guess. Okay.
Exactly.
Dave, any views on this? Do you want to live in a world where everyone's a critical thinker? Would that be a good idea?
I think that's fine.
Yeah?
Yeah, I think that's totally fine. People know that.
They're worried that, like, wherever you go, like, you know, you're on the tube and yeah.
There's a sort of education class system that exists now. So even if you say good evening to somebody, they can immediately tell whether you went to university or whether you've got some sort of qualification. So we do have that. We do have that education bias, where people are doing PhDs, masters. You're not really nowadays. You're not really an educated person, at least unless you've at least done a master's degree. I think that there is sort of this inflation going on where everyone's
kind of arms race of education.
Yes.
Yeah. Okay. Elizabeth, where do you stand on this?
I mean, that's somewhat prejudiced to be able to tell if someone says good evening. No, I definitely understand what you mean. Like, there is definitely preconceptions of people who are not as educated, but at the end of the day, that is the workforce. The workforce are the sheep, and they aren't the critical thinkers. And I don't know. I understand what you're saying of is everyone a critical thinker a good idea? Because at the same time, no, because you do need the difference to have a difference. Like, that's what society's built on. But then, is society made wrong in the first place? That's a whole other question.
Okay, well, can we move on to that? I mean, like, take this gentleman here. He's actually got a PhD and he's a professor. But say good evening.
Good evening.
See what I mean? I mean, like, can you tell that?
Yeah, you didn't say, good evening, how are you, mate? All right. You didn't say that, did you?
Yeah.
If you had said that, I would say, I'm not treated by this doctor. Absolutely not.
I mean, you're a doctor. I mean, do you think that the way you speak actually
in your final exams, you do have a 3-hour practical exam where you have to talk to patients, and you have to stand on the right side of the bed. You have people with clipboards watching what you're doing and what you're saying and how you're saying it, and you have to appear professional. You have to.
So you think having the right voice is really important in that?
Is useful. Yes, it's definitely useful because it just reassures the patient that if you say something in a sensible voice. I had a friend who was a GP, and his brother was all right, mate. It was a very Cockney accent. And I couldn't believe they were brothers because he was so posh, and his brother was so Cockney. It's just unbelievable. I know that's a bias, but we couldn't believe that.
But I mean, in a way, the patients have the bias, so you've got to kind of play to what their biases are, because they need to be reassured.
As a surgeon, if I said, "Look, I'm gonna give you a hip operation," all right, mate, how you doing? Would you like a hip operation? You know what I mean? He would say, "Oh dear, I don't think I have an operation in this hospital. I'd like a second opinion, please."
But I mean, is that is that a health issue? Is it about society? Elizabeth, what do you think?
That's definitely a societal issue.
Yeah.
I don't think it should have it should have no bearing, and it definitely does. I can know people that would be a lot more funny if they had a bad accent, but at the same time, I think that's more of a progressive thing because
If a barrister had a stutter.
Yeah.
I know. I mean, there was that politician not too long ago with the speech impediment. I can't remember who it was. I think it is getting more common to just kind of accept how people are as they are, and they don't have to have the...
So you think that is kind of disappearing, that sort of judgment about accents?
I definitely do.
Yeah.
I think before you wouldn't be able to get away with dressing alternative and then still turning up at practice on surgery, but now you get doctors in jeans at a GP surgery.
As a medical student, people would be sent home for wearing jeans, but obviously now it's changed.
And what do you think about that?
I think they should be well dressed. I think, if you see your barrister, you expect him not to turn up in a t-shirt and jeans to court. You expect him to dress up smartly because your life is at risk, or your.
Okay. So there's a little bit of necessity to this.
When I had we had some German doctors that came over to study here, and I had to lend them ties because they didn't have they hadn't brought a tie with them to work on the wards.
And a doctor needs a tie?
Well, at a major London teaching hospital, yes. What
Interesting. Why?
This was about 15 years ago.
Right.
That's really interesting. I would never have thought that. I think I don't necessarily appreciate the fact that the working environment's getting a lot more relaxed with clothing. I think it's quite nice to have different outfits. Like, it's a Monday, I put my suit on, I'm going to work, and then on the weekend I get to wear my jeans and all my cozy jumpers. I think that is appropriate.
I mean, we're coming on to a thing that's not been discussed much, and we kind of touched on it earlier on, funny enough, which is like, what is the style, what is the fashion of genomics? Do we need to think a bit more about what is there enough of a look in terms of, what a genomics, be they, a bioinformaticist, a geneticist, a clinician, should there be a bit more of a genomics look? And should there be a kind of uniform, and what should it be?
I mean, I think it's completely dependent on your worldview. Like, as soon as someone says genetics to me, I think of like a young new scientist with cutting edge, with a white lab coat. But then if you say science to someone else, then they think of an old guy with glasses and crazy hair.
People have all watched the film Frankenstein. People have all watched Blade Runner. People have all watched Utopia, which gives a very negative output to science. Basically, scientists are meddling with nature. As I said to you, when IVF treatment first came out, there was a big uproar about IVF treatment. There was a big uproar about heart transplants in the UK. They were rioting in the streets, so it was very serious. But in time, people accepted these treatments. And now it's perfectly normal. Now you can go to an IVF clinic, you can book it like you book a pizza. That's how easy it is to get IVF treatment. So it's completely changed now. People's perceptions have completely changed. And they would do the same thing in genetics. Genetics will change, and people will be more willing to accept geneticists as...
I mean, but what about this question about scientists...
Not mad scientists.
About the mad scientists, because it is a kind of trope, it's a kind of meme, the mad scientist. Is that damaging for science in general?
I think what is also damaging is people's trust in doctors. So they did that experiment where they put a doctor in the room and then they told it, keep pressing the button, and the voltage goes up and up until the person dies.
In the basement of a university in San Francisco, and I think they were probably high on various drugs. But the funny thing is, the woman kept pressing the button, even knowing the guy was in pain, and it shows a sadistic side to the human nature. That this is why some of these games are very popular. My nephew loves to play this killing zombies or killing other people, and he loves the blood and gore. The heads blowing open. He loves that sort of thing.
I mean,
I was just gonna. I was just going to add on that. Like, I think this is why the ethical approval that needs to be done for the genetic testing is going to be like the next step in its development. Like, when you think of, there's already been the CRISPR babies in China already in there, and now they are in the gene pool. That that's never going to stop now. That's the first stage. Now there needs to be more testing and more understanding before
CRISPR to be used prenatally in pre-implantation diagnosis. Would you, if a patient had a genetic disease, would you approve
or does
of
it
that
depend
or
on who's
not?
doing it?
In pre-implantation diagnosis, what happens is you fertilise the egg, you then test it, you wait till the 32 cell stage, you take one cell out, you test it for
Vinny, let me just interrupt because we've got a person vaguely interested.
fibrosis.
Come and sit on the table. It makes it look more busy, especially where we've got these extra camera people.
I think that's completely right. Like at the end of the day, people have their own choice, and but this is it. My opinion of this always depends on when you think life starts. Like life starts either when the egg fuses with the baby or when it's actually born. Yeah, my personal opinion.
Hang on, let me see what.
My personal opinion is when the sperm and the egg fuse together. That's when I think life starts. But at the same time, you are technically killing life, but you're also killing life by not putting a rooster in with the chickens. Like, there's always gonna be waste left over.
Sperm haven't met at that point, have they?
Okay, I just come and have a seat on the table. You can do it. We've got. Yeah, hang on. We've got a new face. Elizabeth, Vinny. We've got what's her name?
Neil.
At the moment, we're sort of talking about, in a way, the kind of image of the mad scientist, the Frankenstein scientist. Is it damaging for science? Are scientists actually like that anyway? Where you've got these things like the CRISPR babies in China that had their genes edited. Are we kind of a bit like that anyway? Actually, so that's kind of what we're talking about now, and it's gone on to this question about playing with life. Where does life actually start? Don't have to say anything if you don't want to. What was your name again? Sorry.
Neil.
Okay, we've got Vinny, we've got Elizabeth. I'm Mikey. What are we gonna?
Gender testing. So say you are in China and you don't want another girl, you want a boy. Would you allow pre-implantation diagnosis for that purpose?
I mean, this is a very controversial topic. I personally wouldn't. I don't think that's necessary, but at the same time, I know in different cultures that is a very different worldview. Like, at the end of the day, it all comes down to worldview, and your worldview is based on the education and the experiences you've had. The reason that the mad scientist is still a thing is because the experiments that we have done in the past are just flat out cruel, but we got away with it under the mask of science. Now when we're stepping forward and getting to the next stage, we need to fully understand the ramifications of what we're doing. Like that. The Chinese doctor who released those kids with the CRISPR editing, that was wrong. He never took into consideration that they are now in the gene pool. What are their reproductive choices going to be? Are they healthy? And it didn't do any long-term studies on how that could affect them. I think there's two real studies that need to be done before we can start introducing any kind of CRISPR technology for embryo selection, which is what long-term implications are there going to be for the children, both just naturally and reproductively, and also how many mutations can you get away with before it actually causes a real problem?
Let's bring Neil into this. Have you got any views on this? I mean,
well, generally speaking, the question was, right, does the mad scientist image hurt us as scientists? Yeah. Well, I'd say I'd flip the question. Tough. That it is what it is. Yeah. The public needs to catch up. Yeah. The scientific discoveries don't go away. Yeah. They're going to happen sooner or later. That's just the nature of the investigative process. We're going to find things, and sometimes people aren't going to be happy with it. Yeah. So deal with it.
Okay. So it's like deal with it. It's up to the science. Is what it is. It's just reality in a way. Is what you're saying. And that's the nature of reality. Sometimes reality can be hard.
Yes.
Okay, so are you worried about this question of this mad scientist image or the Frankenstein image? Do you think it's detrimental to how scientists are perceived?
I'm more worried about the arguably growing trend of general anti-intellectualism. Right. I mean, the mad scientist image kind of plays into that, but ultimately it would have no power without that.
So it's almost like the anti-science thing, and can you give us an example of that? Probably something we've all heard of. Anti-vax, yeah.
Anti-vaccination kids.
Yeah.
Oh,
Yeah.
God, don't. Let's not get into that debate, please.
Well, we don't. It's kind of up to you. Here on Talkaoke, you can get into the debate if you want to. You can avoid it if you don't want to. It's kind of up to you. Do you want to go there, the anti-vax thing?
But would you use CRISPR for cystic fibrosis for a
Okay, well, obviously we're on to CRISPR now, so yeah.
These circumstances.
I think I would use CRISPR for genetically engineering children in the future if those 2 tests were done first.
So if you were happy with the results of the
Yeah.
test and how it's going to pass on to the rest of the gene pool?
If you had conclusively proven that there was no long-term implications for the children, because at the end of the day, the only delivery system that we've got which is really applicable is viral vectors. You are inserting viruses into your DNA. We do not understand what kind of implication that is going to have for the rest of humanity. And until we understand that, then there is no chance that we can actually let it happen.
Hang on a sec, Vinny, we've got some new faces to the table. Let's introduce. So we've got Neil, we've got Vinny, we've got Elizabeth. I'm Mikey, what's your name?
I'm Kate.
And
Carl.
well, at the moment we're kind of talking about, we're kind of hovering around this kind of idea about the perception of scientists. Should geneticists or doctors or scientists have a particular look? Have they already got a perception in science? And things like Frankenstein and Utopia and Blade Runner and all these things, do they have a negative impact on science? And we talked a little bit, in a way, anti-vax got mentioned but then decided to be kind of cast away because people didn't want to talk about it. But we're actually talking about CRISPR and the CRISPR babies, and would people use it? And does it matter that science is we've got this Frankenstein image, or is it just kind of Neil kind of says it's okay, and these two are kind of neutral.
But are not. It's other things that are not okay.
Yeah.
In fact, it's the wider social context
Yeah,
which is not
so it's
okay.
the anti-science stuff that annoys you, really.
Amongst other things,
Amongst other
yes.
things, yeah. We'll find out. But that's really what we're talking about here. I don't know if you've got any views on any of those subjects.
I think if popular culture is an interesting one. So if you think of where we were with, books, comic books, movies, or whatever, decades back, actually it was often like the physicists who were the bad guys, and now they're the heroes. It's cool now, right? It's on TV. I think where we are, especially with something like genome editing, that's like the new. It's a plot device now, as opposed to you're exposed to radiation, you get superpowers. Now it's like some mutation, and suddenly you can do this. Sometimes it's good, sometimes it's bad, and they go the whole Gattaca route. I think it's helping people to become a bit more familiar with some of these terms, and then some clever writer will come along and be like, oh, actually, cool, there's an interesting thing. How can we use this in a different route so it's now the hero part of it? And then it drives that conversation, and then the next thing will come along, and suddenly this will be the big bad guy in like the Bond movies or Marvel or whatever. So I think it goes in cycles. So I think it's positive that there is that kind of negative.
But at least is it misleading in a way because I mean often the science is not particularly accurate.
It is, but then that's kind of where it's on us to come back and say, all right, this is misleading. Let's get more involved and figure out how we can get into those conversations or use it as a launching point.
So sometimes the science fiction can be a kind of starting point for some of these conversations. And
I guess the science fiction doesn't do any justice to the science, and I guess it probably freaks people out even more. So
you think it can actually have a detrimental effect?
Yeah, because I think you can, if you've been to the keynote talks this morning, you can see that it's science playing out in action and in the healthcare system, and it's really having a transformational impact. Versus if you then juxtapose it with Frankenstein or some science fiction.
Well, that's also a transformational impact, just a different one.
Yes, but then I guess it gives people false sense of the dangers that maybe sometimes are overplayed and the benefits underplayed, and I think we're battling with that a lot in making sure that technology is adapted.
Do you think that the exposure that we get these days with Netflix and all the other documentaries that are coming around, surely that's going to help combat the whole preconceptions and the misinformation that goes out with sci-fi? Because you get the sci-fi, which is, oh, we can light speed, we can do this and do that, and then you actually get the documentaries, and now just the whole vast number of documentaries that you can see how genetic editing's done in 20 minutes, like the Explained series on Netflix. I think the access to information that we've got is so vast that should kind of counteract misinformed information that you do get from these sci-fi things.
Okay. I mean, does that annoy you when? Like,
Don't. It infuriates me. Yeah, it infuriates me because I love sci-fi. Like, I'm a massive Star Wars fan.
Yeah.
But when you get to like watching things and you can see it's so inaccurate, that pains me hard.
Okay, so all right, at least it's not just me. So we're talking about that. Does popular culture kind of bring people in, intrigue people, or it's actually detrimental because it gives a false understanding about what science does and also the motives of scientists? Because in the TV programs, they're kind of bad people.
Yes.
Where I don't know about Neil, but generally people. Yeah.
I work for a US pharma company.
Yeah.
So.
But you don't see yourself as a bad person. You're a researcher.
Well, there's you can say that the purpose of science is. Ethically neutral. It is simply to discover what is, and we asymptotically approach the truth, whatever it may be.
I mean, do you think that the science fiction can have this detrimental effect? Actually, be counterproductive. It intrigues people, but it makes them very suspicious, as you say before.
I'll certainly admit it's possible. Yeah.
Yeah. Okay.
I think that's a hugely interesting point. That research is supposed to be neutral. I think, especially when we come back to something like CRISPR and genome editing, there are a lot of different approaches to it from an ethical and regulatory standpoint. So thinking the prevalent way to think about it is, let's slow down, should we even do this? Yet you get someone like George Church coming out saying, this is going to happen one way or another. The more time we take to actually get it out there, the higher the chance of it being done irresponsibly is. But I think it's one of these where, again, you've got to recognize that whatever can happen probably will happen. So I think you've got to be sensible in how you approach that mindset, because again, you can take it irresponsibly, but you can also slow it down so much that you're forcing an irresponsible application to pop through somewhere else. So CRISPR is a perfect example of that, and that's why we've gotten to some great innovation from biohacking, all the DIY stuff, but some of it's not quite turned out well, because suddenly it's forced people to think progress isn't happening, I've got to do this myself. So I think how you position that to the ethical audience around and who are actually making these things right, you can't. It's how do you find that balance really between?
I mean, you can have a fancy ethics committee, but someone could just do it. Some rogue scientist we're talking about here could do it in what's that?
Rogue governments.
Rogue governments, yeah.
I think so.
So I mean, how do we?
You could also say rogue research structures that drive the whole academic machinery.
Do you think there are rogue research structures?
Yeah, the whole system is.
Yeah, tell us a bit more about that. That sounds interesting.
Well, I guess
Name and shame.
Over 50% of Nature papers cannot be replicated. I guess that's the statistic that.
So you think that, in a way, is a structural issue with how journals work?
Well, it's the whole mechanism, I guess academics' currency to exist is a publication, and and then it generates ability for you to acquire more grants, etc. So you become part of this vicious cycle. So you become hungry
for publication in the best journals. Is there a better? How could it be done in a better way, though? Is there a better way of doing it, or is this kind of like the best, the worst system imaginable, but try and imagine another one kind of problem?
Well, someone today said that academics are the worst enemies of themselves because they don't collaborate. I think at all. There's that again very narrow-mindedness of academics that it's their project, they're working, and I guess fostering collaboration would probably be one way to kind of unlock the problems of the system, but it's one of many. We probably have to then think about it.
So collaboration could help to change that system a little bit. I mean, do people agree that the system is quite flawed in the structure of how papers come about?
I think the collaboration issue is a really good one to touch on, because we always thank Watson and Crick for DNA, but let's face it, they weren't the ones that did it. And I think if the freedom of information for all of science was approached to everyone, then the advancements would take so much easier. Like, I remember I'm writing a paper at the minute, and I have to work through 3 different websites just to get access, or you have to pay for that article, and it's just pointless, because at the same time your understanding is only ever going to be gained if you share it. I think accreditation where credit's due is always important. I think some of the factors of award ceremonies, like you can't get a Nobel Prize if you're dead, not necessarily fair, but I think collaboration will be the next step of how we can improve everything.
So collaboration is an important part of maybe changing the structure of how science works. Neil, anything on this side?
Oh boy, do I have some things to say about this.
Yeah.
All right. Well, the problem with journals and such is ultimately a problem with how we distribute power in our society. Right. The incentives that journals have to act the way they do is money. Right. And basically, they want to enrich themselves, and they don't care how they do it at the end of the day.
Yeah. And haven't they got a bit of interest in scientific knowledge and actually?
Some of them do, but they will ultimately they can ultimately expect to be drowned out by those that ultimately don't care. And that is basically, if you ask me, the source of most of our problems that we face today.
So the economic system behind it is the
Absolutely.
problem. Okay. Do people agree with that? Is it the economic system behind, I guess, a whole of academia, but also how journals work? It's this kind of, also this dog-eat-dog thing that if you try and do it in a different way, you're just kind of, burn out, I suppose. Yeah.
Absolutely. If you try and do it a different way, you've got to overcome the enormous inertia of the people, of the institutions who are set up to do it the way that it is now.
Okay. I mean, what do people think about this? Can we do science in a better way, or are we just kind of stuck with this system? Is it about money? You say yes?
Money's all about sponsorship. If I get an article that everyone really agrees with, and wow, I found this something amazing, who's someone going to sponsor? Me and my research projects.
Yeah. So it's all about your name and.
Of course it is. Like your name counts for a lot, especially in the scientific community. Because if you've done one horrific experiment once, no one's ever going to hire you again.
Right. Okay. So it can also work the other way. Yeah.
I just want to ask about that scientist. Was it Yamanaka who won a Nobel Prize for being able to reverse engineer cells into stem cells?
Yeah.
Did he not? And he was he won a Nobel Prize. Was found out to be a complete fraud.
Right.
Was that true? Was it? I didn't know what happened at the end. Whether he was found out.
Does anyone know a bit more about that, or we're just going to sweep that one under the carpet?
If I remember correctly, then he'd actually copy-pasted some figures from a different publication.
Right.
And amazingly, he won a Nobel Prize for medicine for this.
You can go a long way with this, then, basically.
Wow.
Okay, I mean, so I guess the broader, more productive question is, there are kind of bad dudes in science. We've heard two recently in the last few minutes about the CRISPR babies and this guy Yamanaka.
I went to a conference where they were praising him, and they said we've just understood his paper's just come out. This is great research. This is going to change the whole dynamics. We can now create stem cells from normal cells. We'll be able to regress those, put them into joints, and put them in and regrow all your joints. You won't have to have a knee or hip operation. We have to take normal cells, put some enzymes on them, make them into stem cells. He won the Nobel Prize for this. So
okay, I mean, so we do know there are bad dudes in science, and they tend to. What's that? Anyway.
One could argue that he's still enabled the field to progress subsequently. I guess someone found out that it's the wrong method, and
so the idea was a good idea in a way.
You could say that it's like what are they called? That doesn't matter. Any press is good press. You could.
Okay. All publicity is good publicity.
Stem cells from fetal cells, so it's possible. But that great idea, because you use the patient's own cells, you can convert their own cells back into stem cells. That would be brilliant if you could do that.
Okay, so I mean, sometimes the bad dudes can come up with interesting scientific ideas, even if they don't do the proper research. But where do we want to go with this? Can the institution of science can it be improved, or is it just impossible when we live in the economic system we live in? I feel that that's your view on it.
Pretty much.
Yeah.
Pretty much.
Yeah.
But it's possible to change an economic system.
Okay, so you would change the whole economic. How would you change
right,
it?
I would. I think that's not for a scientific conference to discuss.
I mean, it impinges on science because you've just said it does. So I mean, maybe it is the remit of science to design a scientifically better economic system.
Well, I think that's for another day.
It might not
to be
be your
honest.
field.
Well, not exactly something to do. Yeah, it's too much to get into here, I think.
Yeah, okay, but so you have got ideas about it, but big ideas that
way too much to get into.
Okay, I mean we've got time.
We're still going to deal with the fundamental problem. It's the basis of Animal Farm, right? You can have a conceptual, pure idea, but fundamentally, as people, we are selfish. We will corrupt.
People will game the system.
That's exactly it. So it's like if you look at where science is now, in principle, it should be a meritocracy.
Yeah.
But that's rarely the case, and it does drive this competition to yes, we're all equal, but be within some of us are a bit more equal than others, because it's an immense minefield of egos out there.
I mean, could it be a little bit more meritocratic and a little bit less egotistical somehow? What would you do? We talked about collaboration. That was one good example. What?
Anonymise it straight out. No one gets any credit. Funding goes to everyone as a whole as opposed to one individual, which would be very frustrating as a scientist who wants to make a name for herself, but that would be one way around it. Then the money just goes to an institution and then gets divvied out equally.
I mean, earlier on we were talking about people's genetic data being anonymous, but maybe the papers should be anonymous too. Maybe traceable through a system of codes.
Referencing would be easier.
You just go anonymous. It'd be really easy to reference.
Too anonymous.
Yeah. I mean, could it work? Anonymizing scientific research?
You'd have to do so much, because I mean, if you're confronted with a paper, especially if you work in the field, you'll get about 3 paragraphs and be like, I know who's doing this. It's really, really tough to essentially wipe everyone's understanding of what everyone else in the field does, and completely wipe out their lab pages as well.
Yeah.
It'd be tough to do. Really, really, really tough to do.
I mean, is it in a way that scientists like this idea of putting a face to the idea and putting a name?
You'd like to know who's in your ecosystem, who your competition is, who you're up against, who you might want to collaborate with, who you think is going to scoop you. It's an ecosystem. This is the issue with it.
But is it one that you like being in, or?
I mean,
a bit of both.
I'm a commercial person, so I enjoy I enjoy the fight in there for sure. The conflict's kind of fun, but it does take away from just actually if you're trying to get the best research through. It is a dynamic that you need to contend with, and it's not necessarily the people who are doing the best research that thrive in that environment.
Yeah, and would it, if people didn't get recognised?
Almost definitely not. That's why they're in research. If they if they enjoyed, they would not be in academia.
Why would you say that?
Because academia has that. So the reason why I went into academia is because it was meant to be apolitical, and you did something for a cause that you believed in, and that was it. And then it turned out not to be. So I crossed over to the commercial side.
So you're saying that it's supposed to be apolitical, but it is hugely political.
Yeah.
Okay.
One thing you have to point out is everything in science is named after someone in science. Like, the reason scientists get so massive and so famous is because their name's on it.
Yeah.
If you completely took that out of the situation, it would really bum me out that nothing would be named after me. But it might do someone in the future, you never know.
Last week we were doing a gig at the Crick Institute. Would it be just the Anonymous Institute, or what would you call it instead?
Yeah.
The Bio Research Institute. Do we need to have these names?
Do you know what? It takes someone really high up there to make this point and say, from now on, I'm going to put all of my papers through under a pseudonym or something, and just make the point that they want to be known for the quality of their work rather than their reputation.
I mean, they've done it in literature. In literature, there is a publishing movement called Luther Blissett, where people just publish as Luther Blissett, who's a footballer that used to play for Watford. Anyway, it's not me giving.
Then again, a more cynical look at how that might work. Like, look at J.K. Rowling, right?
Yeah.
She published that detective story under a pseudonym, and nobody cared. It was rubbish.
Yeah.
And then her publisher leaked that it was her, and suddenly everyone bought it.
So the name is kind of important, more important than the content in a way.
Yeah, much as I would wish it wasn't important, it is important.
Okay.
Had to do it, that would take away the problem. Like, instead, I think one fundamental thing that you could do that would make it a lot easier to support funding and stuff is just use your institution. So instead of saying, it's John Smith, it's the University of Birmingham has released this data, or King's College, because you can still have that competitive nature, but then there's a lot more to be likely collaborations because you have to work with other people in the institute.
So it's more about the institution, so you don't have names, but you have university names or institution names. Would that work better?
Wouldn't you be at a disadvantage if you're from a smaller institution or a less recognised one? Be like, nah, what's going on here? As opposed to if you come in with like a big name and people know who are there and everything around it.
But I think that's already the case with academia anyway. Like if I go for a job application saying I'm from Cambridge, people are more likely to give me a job. I hate to say it, but it's just... I think there is still always going to be a bias in whatever you take, but if you are a researcher and you say, oh, this is the University of middle of nowhere, if it's a really good paper, people are more likely to listen and look at it. But I think a name is very singular. You can't support funding with other people with just a name.
Okay, so maybe it could be spread out to the whole institution,
I guess really when you say that data came out from X institution, you're just taking the naming problem to another level. It's not, I guess you should have a bioarchives where you just have the title of the paper and the findings, nothing else, no source.
So you'd go radical and just take out names altogether, even
because otherwise you're comparing at a different level.
Okay.
The only reason I suggest names of institutions is for collaboration efforts, because it's a lot easier to share information
so
with someone down.
Compromise in a way.
Yeah.
I mean, could that ever work? Do you think we're going in that direction in science? Are we having more collaborations, or are we going in the other direction, where it's more about names?
I think in theory it could be imposed, but I don't think anyone's ever really going to go for it off their own back.
So you'd have some higher authority would have to, like the Minister of Science, to impose it, basically.
The problem is that when you're looking for an academic job, one of the first things they say on the advertisement is how many papers have you published, which journals have you published them in. This is all very, very important. So,
but you could still say that if they were anonymous journals, they would still
take credit for. You might be the fourth author or something. The first, these have to be first author papers. So you can only really put on your CV. You always list your first author papers. All right, you might be able to list some of the other papers, but usually employers will look at the first author papers, because otherwise you may work in a big team. You might be the sixth or seventh author. You've done virtually no work, really. You've just put your name on the paper. So really, you have to be first author. So the problem here is funding. I know at Imperial College, the professor will get more funding if he's written more papers, and he's put them on the website. So all the papers his department's published, he's put on the website. His group. Could
it be done in a better way? We've talked about collaboration. We've talked about anonymity.
The other problem is that all departments and all universities have league tables. So you want your research to be with your professor. He gets the funding from cancer research or wherever, and then he can then give the money out to do the research. So, but without that sort of system, I'm not sure what other system you're going to get, because the elite universities are always going to get the best students, and they're all going to get the top.
We're kind of stuck with this system despite its flaws.
Well, I was amazed how elitist Imperial College is. They won't take anyone. They will only take straight A students. Not even if you get a grade B in any of your subjects, you will not be allowed in.
Wow.
That's it. That's how elitist it is. So they have a league table. So being prestigious is a critical situation for most universities. Where they are on a league table is very, very important.
So in a way, we're kind of going more down that road, and it's more about. And
to get your next job, you need to have published. For me to get my next job, I will need to have published at least 3 or 4 papers, which have to be in good journals. Otherwise, the other competition is going to be too much. This is the problem.
But you don't see a way to sort of change that. You think that's basically what we're stuck with.
Well, you are ranked and you are marked on how successful you are on the papers you've published, which journals you've published them in, if you've got them published.
I think one change that needs to happen in universities is it's not necessarily the researchers being the professors, because I've had cases where I have had the worst lecturers in the world who cannot explain what they are doing, and it's so frustrating because you know that they're intelligent and you know that they know what they're talking about, but they can't put it into words. There's a lot. I've noticed a big push in academia recently to, instead of having researchers as lecturers, actual teachers as lecturers, and I think that will be a really good step forward, because what you say about having to release so many papers a year, that's a lot of pressure. Doing that on top of teaching, that must be very difficult, which is why it shouldn't be one and the same thing. You should be a researcher who can lecture on the side, and you should be a lecturer. I don't think there should be that crossover as much as there is.
Okay, I mean, so a good researcher is not necessarily a good lecturer.
Not at all.
No.
Quite often it's the best researchers are the worst lecturers. There's definitely a move for people to be kind of teaching fellows and that kind of stuff. I think the other thing that often goes unmentioned, I think people from outside academia don't really have an appreciation for just how cutthroat the academic world is. You go in, there's already competition to get into some of these top universities, where that's why they're so oversubscribed that realistically straight A's is the only differentiator they can make, and even then it's like you have all these sorts of other criteria. If you want someone to then go on to do a PhD, again, you're already in competition. You have to have done X number of projects, possibly been on a paper. Then if you want to go into a postdoc, again, like it kind of, the pyramid narrows and narrows and narrows, and then the real kind of differentiator for a lot of it is, what have you published? What's the highest impact stuff that you can do? So one thing you could do is think, right, if that structure exists, how do you... One thing that you could do, which would be quite unpopular, is how do you disencourage people from wanting to pursue academia in the first place, rather than create, more. It's just how do you.
So it's a kind of pyramid scheme with a very few people on the top.
It's just from it's like in evolution, right? Your selection pressures are so intense that it does create, this arms race. So if you can remove that selection pressure, it just calms things down a bit. And
the power. These big professors, the chairs of the department, they get the funding from Wellcome Trust and places like this, and so they can decide where to do the research.
So they've got huge power.
They've got huge power.
I guess there is also another aspect to it that those big professors, they're put in a role of managing people and being really project managers and almost like CEOs of their own company, aka the lab, and they more often than not they have no idea how to manage people, how to manage resources, how to they get no training, and they're just thrown into through that pyramid scheme into making decisions for everyone.
I mean, in a way, now we've identified 3 different roles. One is this kind of management role, funding gravitator. One is the lecturing, and another one is the research. And there's 3 different roles which are kind of not necessarily compatible with each other. Anyway, I think we kind of like hit on a lot of problems, not easy to resolve. I think I'm going to call an end to this session just because I'm running out of voice. But and my brother was supposed to be helping me, but he's gone off. He's actually a researcher and a lecturer. We could if he was here. But anyway, he's supposed to be doing the next session, so maybe we'll get him in the middle of the table. But let's just get some final thoughts on this one. Do people at least see the progress of science, like the development of let's say maybe in the genomics field, but maybe broader? Is that happening despite all of these flaws in science? Do people have faith in how that's going to progress?
Inch by painful inch, it's going to come.
Okay, so it's going to be painful, but it's going to happen.
Yes.
Okay.
I think it's a miracle. We now have the genome mapped. As humans, we now have the power with CRISPR to change the future if we want to. The question is, how much do we want to change the future by? And would it be ethical? Just because it can be done, amazing, as you saw in China, amazing things can be done if you use CRISPR and you apply it to babies. But do we want to go, just because the technology is there now to do it, should we do it?
Okay. Final thoughts?
I think the technologies in genetics has advanced beyond all compare, and society and education needs to be the ones to catch up sooner rather than later.
Science is moving. It's not that it's not moving fast enough. It's moving too quickly for society.
No, it's moving at the perfect speed. Everything else is moving too slow.
Okay. Society's moving too slowly. Science is moving at the right speed.
Education system needs to catch up. It's not good enough.
Yeah, I'd back that, to be honest. I think progress will happen regardless. It's just how best we can adapt to it. That's how I set my stall out. So get ready for the future.
Okay, well, we're trying our best here. Final thought?
I think there is a lot of information out there. I agree, science is moving at exactly the right pace. We need to catch up. I think we as humans need, I guess, to get more tools to be able to really synthesize the information that's already out there a bit better. Yeah. So someone has to find out how to read 1,000 papers a day very fast.
I mean, and also that dissemination, just as a final sort of question, and talking about society needing to catch up, is that actually a responsibility of society or the responsibility of the science institutions to help the rest of the world catch up with this pace of development?
It's a collective responsibility. We'll have a part to play in it. As scientists or people involved in and around science, it's for us to make it easier for people to find the right information, and likewise for everyone else, recognize that this is something that will have an impact on my life or could have an impact on my life, and start to look for that thing. So everyone's going to kind of find that middle point to meet where the correct information starts to flow.
Okay, so more conversations. A final thought?
Society determines that science should happen. So society is the one that should accept how to deal with the consequences.
Okay, so the onus is really there on society. We'll leave it for that. Thanks everyone. Give yourselves a round of applause. And thanks to Rick on camera. We'll be back for the final session if I can track down my brother and get him to actually do this job, because I'm running out of voice, but you will see how it goes. Thanks very much.
Right, so who have we got round the table?
Mikey,
welcome.
Isabel,
welcome.
Prince.
Sorry?
Prince,
right. Mikey, Isabel, Prince. I think 3 people is probably the limit of what I can actually remember, but we need more people. Right, now, what I want to know is, what have you learned today? Just the first thing that comes into your head.
Well, I've learned that for patients going through 100,000 Genomes project, it can take quite a long time for them to get results. Just literally found that out.
It's going to take a long time for the patients to get results.
It has at the moment currently for patients that have gone into it. For a particular patient that's gone into it, it's taken them a couple of years.
How long is a long time?
It was 2 years before they heard, and then they didn't have a result at the end. Okay. So it was, still teething issues, I think.
Wow.
That, yeah.
Okay, what have you learned today, friends?
There is, so I work in a field where you put genes into the cell and get the medicine out, get the antibodies out.
Yeah, come and sit down.
There's a kind of issue that happens that I have never encountered before. So
something that happens when you take the cells out.
When you get the medicine out of the cells.
Out of the cells and it's metabolized.
So how it works, usually you put in and you get what you need out, but there's a kind of error that happens that I've never seen it happen to me, but it's happened to somebody else, and maybe I haven't seen it because I'm not looking for it. So maybe there's something I should probably look for.
That's cool. That's a cool observation. Right. Hiya. But well, first of all, what is your name? Can I ask you that?
Yes, Julia.
Julia. Now, Julia, when I say to you, sorry? Julian.
It's hard to hear.
It is hard to hear, especially if you're deaf like me. Yeah, put the microphone closer, then you can speak and then I can hear you. Now, Judith, what have you learned today? What's the one thing that you've learned today? Off the top of your head, what comes straight into your head? It could be something tiny, something massive.
That we need 40 exabytes of storage space for the Human Genome Project by 2025.
40 exabytes.
I don't even know what an exabyte is.
No, it sounds big. Sounds big. Yeah, Mikey sounds big. Okay. So we've got Mikey, Judith, Isabel, Prince.
I think they've made that up. There's no such thing as an exabyte.
Anyone who knows what an exabyte is, please come and sit down and explain to us. Come and have a look.
There's one thing I know about, you shouldn't say anything on this Talkaoke table that will encourage the bioinformatics people to come, because then you're just going to have a conversation that you're not going to understand.
Mikey, that's what we're here for, to have lots of conversations that nobody understands. That's what's been happening all day long here. So, Isabel has been talking to me about how long it takes for the 100,000 Genome Project data to come back.
Prince has been saying about some medicine that when you take it out of a cell, it's completely different. And Judith has been talking about how it's 40 exobytes for the entire genome project. Have any of you got anything to say in response to any of those facts?
I need to think about it.
No? Something comes to mind?
Go.
Mikey does.
Don't I get? I learned something as well. It's not.
Oh yeah, what did you write? Sorry, Mikey.
I learned that the what's it called? The Pacific. What they called? Pacific Bio or something like that.
Right. Yeah.
They've got a machine that uses laser beams to read DNA.
Yeah.
I didn't even know that, and it's different colours. Different base pairs are different colours. I didn't know that.
Good.
Yeah.
That's good to know.
One thing I learned. One thing I did learn is how much data you need in order to really refine the risk factors. So you do all this whole genome sequencing. You actually need like a good, 500,000 patients to actually refine the risk factors. So we need to figure out how to store all that exobytes of data because it's actually needed in order to understand and get data out of all this data. Get information out of the data.
So what she's saying about exobytes makes sense to you?
Well, I think so. In general, yeah.
An exobyte is.
But you think? But what we're saying is we need a lot of data, and you're saying, we need a lot of data, right? What do you? Any views on data, Prince? On the amount of data you need for genomics? Are you a genomics person? Because what you told me isn't really a genomics thing.
No. So I'm not really a genomics person. So someone who, from my work, who saw me here, who are genomics people, they're like, you don't belong here.
You're like, you feel like a fish out of water.
No, so I try to explain people that I'm interested in genetics, but not in genomics, and I think some people don't really agree with the separation. But I'm more interested in how genes.
What is the separation between genetics and genomics then?
So I think genomics is getting the whole story, the whole data, the whole book, right? I'm interested in how some snippets of that book interact with the other, and how those interactions.
You want to say something about that? You're nodding your head there.
No, just agreeing. So.
Come and sit down, everyone. Come and sit down. Let's hear what you heard about. Bring your beer, bring your wine. I'm still waiting for my beer, and there's too much of a queue. You've got your juice. Bring bring some people. Yeah, go and bring some people, Prince.
Well, I will say on that we can get all our genetic information, but again, it's that gap at the moment about what that really means and how much the environment actually impacts. So there was a really interesting talk earlier about what is race, and race isn't a genetic thing, it's a social thing. Very good.
What is a social thing?
Race.
Right.
So all of these things like ancestry, DNA, any kind of thing trying to figure out your ancestry, it's actually, we're all just one big mixing pot, and there are like very small amounts of variation that will make you geographically linked to a place. But really, a race is a kind of a social construct. So
genetics, it's not there.
Exactly. So with diseases as well, if we're trying to link that back to a particular race or heritage, then again we kind of need a lot more data, and then we need to homogenize everything. So.
What were you saying?
No, I thought that was a very interesting talk.
Yeah, that was interesting to talk to. Sorry, what's your name?
My name is Aris.
Aris?
Yeah.
And did you go to the talk about the race and the genetics?
No, I didn't go today to that one.
But what Isabel was saying is that there isn't such a thing as, from a genetic perspective, there really isn't such a thing as race. Come and sit down. Come and have a sit here, and we'll get on. So, what do you think about that?
You said there's no such thing as race in genetics?
From a genetic perspective, it's like a socio-political economic term that came up a couple of hundred years ago, but it's not got any genetic basis to it.
Well, if you think of it as from an ancestry perspective, then you have clustering of different genotypes in populations in different continents. So the Europeans will have lowest numbers of variation, but they will have similar types of genetic variation compared to Asians, who will have a different subset of variants compared to Africans who have other subsets of variants. And then this is the typical problem of low impact variants with complex disease.
So what you're saying, Aris, is that actually functionally it's important, that it's still functionally important when you're doing your thing. Sorry, let's hear, what's your name?
My name Arūnas.
Arūnas?
Arūnas, yeah.
Arūnas, yeah.
That's a Lithuanian name, so it's not very usual.
Okay. And do you have? We've been talking about race and genetics, and there was some talk saying that there isn't really such a thing as race in genetics. But Aris is saying that actually it is a certain thing that you have to take into account for certain diseases. Is that what you're kind of saying? Yeah. Any thoughts on that?
Race? Sorry, I.
What you mean, like if someone's from an Asian background or from a Caucasian background, that kind of thing? Hang on, go on.
Yeah, there is definitely different acceptability to various diseases based on the race and gender.
But I suppose what you're saying, that definition that we have culturally isn't the same genetically. I think that's what you're saying. Let me just say, you were saying something there, Isabel? What do you
we were just discussing how, certainly there are genetic clusters in terms of geography, and that in fact even within these big cohorts, like African cohorts, you have a lot of genetic differences between very small areas. They were saying maybe you need to go down as far as 10-kilometer differences to really pinpoint where you're from, but it's not necessarily a race
so
thing.
It's much more geographically limited,
and it depends how far back in time you go as well, because over time there's been lots of mixing. So are you African descent of the last 100 years or the last 1,000 years?
So you're not saying that it doesn't exist as geographical changes, it's just it's much more complex.
I think the geographical stratification is more accurate, is a more accurate term than race.
Okay.
That's probably a better word to use.
But right, everyone, just going to bring in a few more people. We're just talking about genetics and race and genomics and anything you want to talk about. Come and have a seat. Come and have a seat. Come on, let's have a seat. Look, we provide the seats. Unfortunately, we don't provide the drinks, but we should,
It would have increased attendance, right? I gotta say, it would have increased it. Whoa, that's how I sound like. Testing.
So I haven't had a drink yet. So Mikey here is going to kindly go and get me a drink. But in the meantime, you guys have got a drink. So tell us what your names are.
My name is Sabir Jamal.
Sabir Jamal?
Yeah.
And you?
Ridwan Sheikh.
Sorry?
Ridwan Sheikh.
Ridwan Sheikh, okay.
Yeah.
And then so, we'll just go on first name terms, is okay?
Alright,
And then we've got Arūnas here.
Yep.
And Isabel and
Aris.
Is it? Yeah. Aris. So we were talking about how a talk that some of these guys went to. Oh, brilliant, Mikey, good work. So we were talking about a talk that some of these guys went to that said race doesn't really correlate to anything in terms of genetics. And then we started talking about how it could actually there's geographical differences. There are geographical differences, but that's much more specific, and that's how we could kind of think about it. Have you got any thoughts on that?
I didn't hear fully. Was it geographical differences?
Difference in race.
Well, Isabel will explain.
Okay, so it was saying that race is more like a social construct, but actually if you get down to the genetics, there's very little variation between different races, and so the differences are really geographically based, and it depends how far back in history you go, depending on the mixing of the migration and everything. So if it gets into kind of a grey area if you're talking about genetic risk factors to do with race. It's not really, I think, scientifically accurate. So this is what the talk was all about race and genetics.
Come and sit down.
I'm not an expert in it.
Any thoughts on that?
I don't feel like I'm an expert in population genetics that I would really know
honestly,
if race played a big role. I assume it always would do. Hence why we have race-based databases. Nomad is
I have a big problem with like direct-to-consumer genetic tests because they're kind of cherry picking. You've got a huge European data set and then small population of like African genetic data sets and Asian. And the speaker was saying that if you are of like South European descent, let's say, actually there's not a big genetic data set to represent that. So what you might find when you get these tests back is you've got an African kind of descent, but that's because it's kind of filling in the gaps of what's missing in the data.
So when you mean about like the 23andMe things? Yeah. And he thought, but is that what you're talking about, or you're talking about something else?
I was just assuming because Nomad, what does it stand for? Genomic aggregation. What does it stand for?
That's a very good question.
But Nomad is a big aggregation of genetic populations, and it compromises of whole genome sequencing of about 60,000. I think it's gone up to 120,000 individuals across the world, and they base they subgroup the data into regions. So you can easily see that there are differences there, but I'm not sure if it.
Oh, sorry, Aris, any final thoughts?
Well, I just think that as our friend there is saying that, it's population genetics has some importance depending on what you're looking at. So as it's shown in Nomad or 1000 Genomes projects, where it's stratified by population.
Is it just a problem that, there is obviously geographical differences in terminology to a certain extent. Is that right?
Yeah. So, for example, the other day I was investigating a sickle cell anemia variant, which is only found in Southern Europeans, for example, or Northern Africans, I think. So
that's definitely a geographical bias. This is how you describe that. That's the problem.
Yes.
You're going to say something now?
I don't know, I was just not about that because I couldn't really tell what he was saying, but I don't know, I just had a random thought of how weird this is.
What?
Sorry. Like this whole setup, it just interjected in my head.
It's supposed to like change your way of thinking because you're talking to people in a different way. So weird is good. And like we need more people. We need a full table. Let's get a few people. Come and sit down. Lovely, comfortable red seat, orange seats here. And then we can come and sit and we can see how. Excuse me, would you like to come and sit down? Come and sit down.
Just hit them with a question.
Right. So. Well, we've already talked to Aris here. I'm not going to look at me in the eye and I'll ask him a question in a minute. Anyway, I think what Aris was saying was he has situations where geography matters, but how do you say that? Come and sit down.
Hello.
Hiya.
Yes.
We're just come and sit down.
What's happening here?
What we're doing is that these guys are trying to work out what we're doing. Well, what we're doing is Talkaoke, which is kind of like a mobile chat show. It allows people to interact with each other who wouldn't normally talk to each other and talk about whatever's on their mind. There's no agenda, it's whatever's on their mind. So at the moment, we've been talking about how we define different geographical areas in terms of genomics and genetics and how that's linked to race and those kind of things. And it seems to be something that people found was a good thing that turned up. Is that of interest to you, or something else that you heard today that particularly like struck home, like something that you want to do?
That's a good topic.
And okay, Mike has got.
Well, there was a guy earlier on the table that was kind of saying that we need to kind of reclaim this question about genetic similarities from the move away from the kind of race argument to say, oh, I've got this particular mutation, who else around the world has got this mutation? And it's already happening with like rare cancers that people have almost formed clubs that I've got this rare mutation and there's somebody in America and there's somebody in Brazil that's got this, and they form these clubs. So he was saying it doesn't just have to be about disease, it could be, oh, I've got this particular genotype.
By social media?
Yeah, like I'm going to link up on social media based on similarities in my genotype, and we've got to reclaim that from the racists.
How do you hashtag that? Do you hashtag the variant? Do you hashtag the HGVS variant?
The gene?
Oh, the gene, yeah, I don't know.
Or the locus?
That's what we got to find out.
Yeah. How do you hashtag your genetic variants? What's your name?
Danilo.
Danilo, what do you think about this? Nothing in particular?
Nothing in particular.
No. Sorry?
What is the purpose of having this group?
So that we can
we have the same mutation, so what?
Oh, why? No, because why do they want to? Because I suppose they want to meet other people with the same polymorphisms as them.
Oh.
Is that right? So let me just, this is Elizabeth, isn't it?
It is Elizabeth.
Yeah, welcome back. Have you got any thoughts on this?
I mean,
hashtagging your mutation, your polymorphism?
Well, I think comparing DNA with people around the world has got some dangerous connotations because you could find out something you don't want to find out. Like I read a story not too long ago. Yeah, because I read a story of there was a doctor in America who was a fertility doctor, and then it turned out that he'd actually put his sperm in instead of the dad's, and then parents found out that way. So I don't necessarily think that comparing
people. It's not always a great idea.
Yeah.
I mean, it'd be a very long tweet if you had to put your entire genome sequence out there, but it could be done. I mean, if you knew it.
I think there's we're kind of converting the kind of clinical side of genetics with consumer, and it's getting into a very dangerous space. So for patients that talking about in the Genomics England, trying to help the support of patients going through that. So after a diagnosis, matching up people with the same diagnosis so they don't feel so alone if they've got a rare disease. That's really good. But just kind of using it in a more consumer, here's my genotype, let's just match with people. It's a bit, again, it's
a bit dodgy area.
It is, and it's what does it really mean? And I think sort of
So do you think
identity.
that's a bad thing or good thing? Anyone got any opinions on that? Consumer versus.
I think that's quite an interesting point because the consumer nature at the minute, the 21, 23 me or something, the data that's actually being produced is nowhere near reliable enough. They did studies of identical twins comparing their DNA and they're completely conflicting results. So I think there needs to be, if there's going to be commercial access to it, it needs to have some kind of governing body to actually make the data reliable.
Do we need a governing body for that kind of stuff, would you say? Regulation? Yeah.
I think that just doesn't apply to 23andMe and genes, but all of social media is, I would say, exactly the same thing, that there's these huge amounts of data out there on us or about us that it's a wild west out there. You can do whatever you want with it without people knowing. It's not just the genetic data, but there's your phone knows how many steps you take and where you go and everything about you. So,
but you don't necessarily put that on social media, I suppose.
But things that you put on social media can be 100% fabricated, but your DNA is your DNA. There's no chance that you can get around.
Unless you put someone else's DNA on there and say it's your own. Anyone thoughts about social media and genetics? No, I mean, is it a good thing? I mean, in the old days, patient groups used to talk to each other on,
Yeah, I think George Church is making a dating app based on your genetic data.
Yes,
so just to throw that out there, that's happening.
A dating app based on your social data. Would you want? And why? Why is it doing that?
I think it's based on the major histocompatibility complex.
Closer.
Can you not hear me? Okay. Yeah. So George Church in the US making a dating app based on genetic information. I think it's based on the immune system, but I'm not sure.
Final thoughts? Do you want to say a final thought?
Good luck.
Thank you. So yes, a dating app based on so it's just to avoid disease. Is that the idea?
I guess potentially. I think again it's much more of a consumery sort of thing. But I think importantly he's not charging people for their genetic data, because that's a big problem I've got. Is that companies currently, direct-to-consumer companies charge you for your data and then make a lot of money off that data, and all you get in return is not very reliable results out of it. So I think that's very unethical.
So who here has done 23andMe or something? Anyone? Have you? You?
I wouldn't trust them with my data, because at the end of the day they're big American companies, which chances are how much of that information is going to pharma. It's going to get sold at some point.
Sorry. Amen. Sorry. That's
I'm sure somewhere in their terms and conditions they have something about being able to share all that data around.
Yeah.
I'm sure. Yeah.
So, come and sit down. Come and sit down. No, come on, we need you. We need you. Right, Mikey.
I think it's kind of like getting your gene done on 23andMe is a bit like getting a tattoo. It seems like a good idea at the time, but you're going to regret it for the rest of your life.
But even against my kind of personal views on it, then I also have to say that we kind of need as much genetic data as we can, which is why we need regulation, right? Because the only way to make sense of all the data to find actually anything clinically relevant, you need as much as you possibly can. But I don't think it should be done through these companies.
Okay. I'm actually thinking of doing 23andMe. Shall I tell you why? I'm hoping to get some Irish genes in me so I could get an Irish passport. And I think that's the only reason to really do 23andMe.
Right. So, has anyone here out there done 23andMe? Does anyone want to defend 23andMe? Because nobody is defending it here.
Well, I read a study about this lady who did the 23andMe test, and she found the BRCA1 mutation, got ridiculously scared. She was actually going to go for the full double mastectomy, and it wasn't until that one doctor was just like, have you actually tested this with an official board or someone actually certified? And she was like, no. It's that kind of data that's actually spreading more negativity.
Particularly dangerous, as you're saying.
Yeah, like the genetic information, the information that the general population know about genetics is getting skewed by all this bad information.
Right, so we're talking about genetic. Let me just tell you what we're talking about: genetic information, 23andMe, and how it might be dangerous.
I can add something on. So I agree with Elizabeth to a certain extent there, because one thing that we don't maybe take into consideration as much is the fact that a company like 23andMe is obviously able to produce the results that they're be able to produce to whomever that requests the service. But not every country in this world, or not every region in this world will have the same accessibility to question those results. And neither do the general population have the understanding to look at those results and make sense of them, or make logical and rational decisions on them. So I think that there is an obvious case here for regulation. What that regulation would look like, I'm not sure, but I think that is obviously a big worry.
A big one for regulation, and we're talking about in different countries being different.
I mean, earlier on we were talking about a global protocol. There should be actually a global protocol for how this is regulated, because it's a global question. When we were talking earlier on about how to encompass the question of global genetic variation, you need to have a global standard for this.
And I think you also need a global standard of like the ethics and the counselling involved as well, just to tout the counselling, because if you're going into like smaller geographical regions, which you need that data in order to get like a really global picture, but these are small communities which might not necessarily have ever been exposed to like genetic information before. And there was one of the talks earlier was saying how like these small populations, suddenly they realised that their where they've come from, their descent was different to what they thought, and it really changed their picture of their identity. And you're really messing with people's identity. So again, it's not something to be played around with. It's actually can be really, really
but this is a
human thing. So
there's all these startup companies that are doing things like this. But people would argue that this is great, because otherwise it would never happen. It's driving innovation, it's driving new things. But isn't that true?
I'm just wondering, what about if Prince Harry did the 23andMe? Would he need genetic counselling? Probably yes.
Prince Harry.
He's got the ears. He's fine. Yeah, he's definitely a royal.
Well, have you got any thoughts on Prince Harry and 23andMe?
Well, one thing I was going to say is, how do you know what information you should report back if it was actually a governed body? So I know that the 1000 Genome Projects had a big problem with incidental findings and where you should draw the line on what you should actually be telling patients.
And who runs this governing body, I suppose? It's who,
Can I just want to say, because we do a lot of science communication gigs, and to me, one of the crucial things about science is the unknown and that's what science is all about. But the public think that science is all about the known. And to me, that is the crucial problem with all of these things, where you have this interface between the consumer, let's say, and the practitioner, is that the consumer expects the scientist to know everything when they're just completely in the dark, just trying to find some kind of sense in it.
If I may add, can I just make one rule in this table? Can we hold the mic ourselves so we can hear each other? Because I can't hear everyone. But second of all, is that I completely agree with what you're saying to 100%. And let's also not forget that most consumers or most people that are not into science, their mindset of where science is like very far back. I mean, obviously, if we weren't around these circles doing what we were doing, we wouldn't know the capabilities of sequencing, what we can do with sequencing. I mean, like, imagine what for the layman or the laywoman would imagine that we know and what we can do. So obviously, I definitely agree with you to 100%.
So do we all agree with that, or was there any one thing in that? How do we tackle that? How do we tackle the problem that the layperson doesn't understand all this?
Well, when I was in the lab, I always thought that it could do with a Channel 4 documentary following us about to see how ridiculously difficult it is. CRISPR, for example, there was some CRISPR going on in our lab, and the idea that we're on the verge of editing humans beyond recognition. I mean, sort of we are, but at the same time, there's like how difficult it is to get it like perfect is really not a perfect thing. So
I mean, many years ago, Mikey and I did a Talkaoke like this in the Science Museum, and we had scientists, PhD students mostly, and people from their peers, you know. And one comment was like, everyone thinks that scientists can make new people and all sorts of stuff, but actually if you look in the lab, we can't even, it's impossible to do anything, you know. Hello, what's your name?
Alex.
Alex, yeah. You can hold the mic.
Oh, thank you.
So, there we go. Right,
hey!
Okay, because we need to be loud, close to the mic because there's so much noise here, but we can still have a good conversation. So Alex, what do you think? What's your thoughts at the moment? Any thoughts on the question of, what are we talking about now? Of about 23andMe and whether people understand what it really means, and if that's a problem, that the general public don't realise that scientists don't know everything?
I read a paper that involved analysis of 500,000 23andMe genomes, and it helped solve a very difficult question.
Right.
It was about prion protein disease, and most of those people must have given their data away and consented. And I thought, well, that's an incredibly powerful bit of information.
So you're saying that actually is a powerful source of information that we can use?
Absolutely.
Right. So what do you guys think about that? That actually we can get a lot of good stuff out of it.
Is 23andMe just an example of Darwin's theory of survival of the fittest, where people who are dumb enough to use it will then act on it? Just a question, really.
Right. Is it survival of the fittest, 23andMe? Or, going back to Alex's question, is it a powerful tool for understanding disease?
I mean, I understand what you're saying about it being a powerful tool, but how do you know that the actual methodology that they're using is reliable? Because I know if you send something here to 1,000 genome projects, it's going to be done in a specific way, and that data will be a lot more reliable. How do you know that they're not actually just making up what they find?
What do you think, Alex? Is it reliable?
The study I was talking about was the 23andMe data was given to a much bigger organisation, a powerful US-based bioinformatics group. So, were they analysed correctly? I don't know, but the information that was given, they validated it, they checked it, and they were happy. So I'm assuming the methodology is okay. I don't know, but I can't imagine they would use it otherwise.
We think the methodology is okay? Is it not just, if they've discovered something, is that not good enough proof that it works?
I mean, I think whenever technology or whenever science advances, it's not in a nice kind of smooth way. There's always this kind of like, in a way, it's the people that are willing to be a little bit more ruthless that actually push it forward. Like I was recently watching this documentary about the evolution of radio and the understanding of electromagnetic radiation. And Marconi was a total bastard. And he didn't really understand the potential of radio, but he wanted to make money, and that was what pushed it forward. And actually a lot of stuff just happened just in a dirty way. Actually
it happens because people want to driving things on. It happens anyway. Do you think that's a good thing? Do you think that's what's going on?
Can I just step in here? I think maybe we should clear off one topic so we can leave it behind. So the 23andMe question, because we think there's some people that have different opinions there. But if 23andMe were forced, or any sort of sequencing that would do any sort of sequencing and do analysis for you and provide results for you, that is not a hospital or accredited kind of healthcare system. If they had to follow the same regulations as the healthcare system and they were regulated, would you still agree with 23andMe?
What's the question? Would they still be, if they were regulated?
If they were regulated.
Yeah. Would they still be in resistance?
No, if they were regulated and they followed the same level of accreditation as our healthcare system, let's say in the UK, would you still agree that 23andMe as a service should exist? That should, because obviously, if it's not regulated and if we cannot trust the results, I 100% agree with you. That then there's a big question mark. But you might have a different opinion if you still think that people should be provided with, if they're gonna, what the probability of them having cancer, what the probability of them having whatever.
If they have a problem with disease. Elizabeth.
I mean, I definitely agree. Like, if it was accredited, then there is definitely a gap in the market. And as our knowledge expands, people do want to understand what is their genetic basis and what kind of things will influence their development of potential diseases in the future. But at the same time, if a private company is getting access to the one thing that you do not want them to get access to, how do you know that they're going to keep it safe? Like, that's the biggest question that I can think of.
Maybe, Alex, come over the seat. Come over the seat.
I spoke in defence of 23andMe, but I did read another report about how they analyse genes and they don't always look at all the variants. So there was a case of somebody who was told they were going to get breast cancer because they had a BRCA variant, but they hadn't looked at all of them. So they clearly they don't have all the science. I'm not going to defend them, but they are a resource.
They're still a resource. Hi, what's your name?
Hi, I'm Patrick.
Patrick, you are rapturously welcome to this table.
Yeah, I've never received that kind of welcome before.
Well, welcome from us as well. Now, have you got any thoughts about 23andMe and if it was regulated, should it be? Is it a good thing?
Well, I suppose it's in the news quite a bit recently because of the slowdown of sales of direct-to-consumer genetic testing, but also they've recently, I think, out-licensed a drug to another pharmaceutical company. I'm specifically very interested in this question because I'm working on a startup company to try to do something similar to what they do, but give patients control of their data, share in revenues, and that sort of thing. So
you've got an alternative.
I have an axe to grind. An alternative.
So give us in one line, what's the special thing about your alternative? This is your moment. What is it?
Basically, what 23andMe does is sells a genotype test and report to their customers, and then they sell the aggregated data or use the aggregated data to develop new medicines that they market. My opinion is that this is okay if patients know that it's happening, but a lot of people actually don't. They technically sign the terms and conditions that says I've agreed to do this, but they're not really necessarily informed about precisely what's happening.
Your company?
Yeah, so we have a different approach. So we allow people to upload data and give them full transparency and control of how it's used. So you can elect to have us ask you every time the data might be used in another application, or if you're an informed altruist, then you can say, I'm happy for my data to be used in any sort of research.
Have you started this? Have you got customers, and do they tick the box to say yes, you can use it?
Yeah, we have participants who join the platform and add data, we also have our own sequencing kits. We mostly work with clinical trials where participants are being matched to a clinical trial. We're also starting to work on some of the same kind of research that 23andMe does. We're smaller. We're only a 7-person company right now in Cambridge, but we're working on it.
Excellent, excellent. Right. What do we think? Oh, we've got 2 questions. Quickly, and then we've got another one over here.
Just for you, really. The question is, are you prying on people's fears that they're not getting the right diagnosis and the right treatment, that they fear that they're not getting out the normal regulated hospital system? Is that
are you playing on people's fears? 1 second, let me just get Isabel's question as well, then you can say both of them.
So I just wanted to clarify, you are giving back information to the patient, to the person, the consumer, about risk factors. No, you're not.
Right, can you answer those 2 questions?
Yeah, and they're both related. We don't give back any medically related information, so we're not saying upload your data and we'll tell you about risk factors. We're actually, the proposition is get involved in research, donate your data to help research, or get involved in clinical trials. So none of our reports are actually medically relevant in that sense. Yeah, and I think it's important that there are genetic counselors and medical professionals involved in that, essentially. I think.
So to answer this question, you're not playing on people's fears, you don't think?
No, definitely not.
No, okay.
That was one of the points I was going to raise about whether we regulate companies like 23andMe to the same standards as hospital labs. The major difference is the support around that. So you have counselling before you even do any kind of genetic test, and then you have counselling afterwards, and you might have psychotherapy for a long time afterwards, because it's a major thing to open that Pandora's box. So this is my major bugbear with kind of the direct-to-consumer tests, is that they lack the support network that the medical world has.
Does the NHS England, well, let's see what Mikey's going to say.
Well, we were talking about this earlier on, and I think that the issue with counsellors is, number one, there aren't enough of them, and number two, they're expensive. So I think you've got to go artificial intelligence on the counsellors, and you could have a system where you've got, overseen obviously by a specialist, but artificial intelligent counsellor, especially in areas with poor health provisions, that could actually be a way to...
Wait, AI counsellor, Elizabeth first,
I can tell you now, I've got a lot of friends that want to be genetic counsellors. There is just not enough funding to get enough in the door. Like, there is such a big market, and I can know if they opened up, because I think the university only opens 1 every 2 years, or few every year, where if they just opened the doors and said, right, we're going to have a massive intake of all these counsellors, then there are people to fill the jobs, just no jobs to fill.
I have an important question. AI counsellors, how's that going to look like? Do you sit on a lounge chair and fill out a questionnaire on a laptop to say, I feel quite sad today? Yes, I do. How would that work? I'm not sure how. The whole point of a counsellor is not just to provide the expertise, but I think it's also to provide that human kind of comfort to say that actually what you're going through is quite difficult, but there is a support network here for you to allay your fears.
Okay. Isabel?
I was just going to follow on from you and say that after I did a PhD, so I've done many years in academia, and then was thinking about becoming a genetic counsellor. But the idea of paying for another 2 years masters in order to train up for it was like, it's on the back burner because of the threshold to get into it. So if they made it a bit more open.
Like there's no jobs there at the moment anyway.
Well, it's hundreds. There are,
So competitive. Like, you have to do so many different assessments and so many different loopholes to jump through, and it's far too difficult to actually get a job that is actually considerably needed, and that need is just going to grow.
Sorry, I have another important question for you. I forgot your name. Patrick. The question is with the way genomics and whole genome sequencing is being adopted by NHS England, do you not feel like they are going to... There won't really be a market for you to really penetrate?
So is NHS England getting your market?
It's a perfect question. We don't sell direct-to-consumer tests as our model. We recently won a grant to work with Genomics England to do exactly what you described. So I completely agree with you. In 10 years' time, the data won't be generated by 23andMe. It will be generated by healthcare systems. So what we're doing is building software to allow patients who've enrolled in projects like the 100,000 Genomes Project to be able to see what's happening with their data, add information of their own to these kind of projects. So our view and vision is that if you could take the kind of user interface from something like 23andMe that gives people, their user interface and the level of user interface you'd expect from Instagram, but apply that to medical research. So to allow patients to see what's happening with their data, control how it's being used, receive reports that have actually been viewed by a genetic counselor or other medical professional. That's the vision rather than selling reports.
Okay. Right. So, are we going to move on, or have we got no?
I just had a sudden question in my mind because I was thinking about the future of like genetics and healthcare, and if everyone's eventually going to have their genome sequence, should we already have whole genome sequencing done as soon as you're born, or should we wait until you're old enough to consent?
Yes, that's something that came up earlier. Let's see what we think.
I actually think you should definitely have your DNA tested as soon as you're born. For the one reason being, sequenced, whole thing, whole genome sequence. You know exactly what you are from day one. For the sole purpose of, if you ever have a problem in future, and maybe you do develop some kind of cancer, you already have the comparison. You can see how much damage and what you've actually been exposed to throughout your lifetime, so you have like that foundation of understanding.
You have like a reference. Alex?
I was just going to say, after a lifetime of working in the NHS, I have come to genomics later in life, and I find it incredibly exciting, the whole development of everything that's possible. So why wouldn't you? Why wouldn't you sequence your genome? Why wouldn't you get as much information early on? And I've just one thing to finish. This is the most bizarre thing I've ever been involved in my life, but it's new, like the whole of genomics. So thank you.
It's new.
And I've got to go. I've got to go.
I
love you all.
Thank you. I will take your final thought. The most bizarre thing I've ever been involved in my entire life. That's brilliant.
Is it?
Sorry?
It's not a conversation.
Why is it not a conversation?
Well, because it's like you can only talk one at a time. It's so unnatural.
Oh, right.
And it's stage managed, and you're in the middle orchestrating it all.
I will have a Mikey have a thought on that one.
No, it works well like that. So I mean, talk about 23andMe. We've been going 23 years with this.
23 years.
But it is a conversation. I don't think you can scientifically say that it's not a conversation.
Okay.
It's certainly a conversation.
I think the only reason why you shouldn't get your genome sequenced on the day you're born is how many years do you reckon it's going to take before the police want that information? Yeah. How many years do you think it's going to be able to keep up that security borderline of no, this is just for health data, not for protection, and then there's going to be so many lobbying, so much work done, and then that wall's going to eventually break down.
Thoughts on that? Is it a bad idea?
I mean, we're already swabbed, right? So, we're already swabbed and things like that, right? So to what more extent other than like insurance companies and things like that? That would be a bigger worry than the police, right. Unless someone can add it to it.
So I suppose the question is, if you had a child tomorrow, none of you look like you're going to have a child, or maybe you can't tell with the guys, but you might have a child tomorrow, would you, and there was an offer to get that child's DNA sequence, would you do it? Would you do it? Yeah, would you do it?
I would do it, yeah.
You would? You said yes, would you?
No, not until there's a reason to. Like a health reason to.
Right, okay. Would you?
If I could sequence it and I could hold that on my own hard drive, I would.
Personally sequence it, yes.
Let's be honest.
I would have, mainly because ignorance is bliss. Why the hell would you want to know that you have a variant that no one really understands, no one really gets? What's the point? You might as well just live in peace and know that you're a child and you can do anything you want. That's the beauty of being a child, right?
Right, Mikey.
I don't think that genetic data would kind of taint the purity of childhood. But you don't have to. It's a choice of what you do with that data. Earlier on we were talking about maybe that data should just be kept almost in trust and it not even released to any database, just completely isolated, either on your own USB key or in the cloud but locked somewhere. And then if you want to release it, then you can just do it with a click when you're ready.
Wait, we've got a lot of people on, Elizabeth.
But what about the personalised medicine argument? Like, you can already tell which drugs are going to work better for some people. You can tell that, and if you get that from the day one, then you'd never be put on the wrong treatment as far as they know. ever. And then that data can only ever be added to.
But what's the point of having done that as a child? If you come out with a symptom and go to the hospital and then be like, I have this symptom, let's sequence you, let's find out what drugs will help you. That would work so much more better rather than do it as a child. Be scared of, let's say I had a daughter, she has potential pathogenic variant on the BRCA gene. I'm definitely going to change how I treat her and what I do with her, rather than if I didn't know and let her live as a child and let her be free and decide what she wants to do with life. Maybe I might cotton wool her and be like, no, actually you can't do this, you can't do that. Or I don't know, like colorectal cancer, you can't eat that. That's going to ruin your body. You can't have a can of Coke. I mean, it's ridiculous. Yeah, you can take it in so much more.
Let's see what the advocates. Let's see what anyone else want to argue against that point. Would you like to say?
Yeah, I mean, I think at the end of the day, it's a personal choice. Everyone waits differently when they want to receive this information. For me personally, I think that if it's possible to identify a condition that might affect a child early and treat it rather than waiting for the symptoms to appear, I would choose to do that. There are a number of pediatric conditions that you could detect by whole genome sequencing. I think it's quite rare. If you were to whole genome sequence 1,000 children, you might have something actionable for the child in 1% or something. And I think the arguments about precision medicine are quite good. If you can solve the problems around privacy and who has access to the data, and you allow people to choose what they want to know and when they want to know it to address his points, then I still think the main problem with it is cost. We can't currently afford to sequence anyone anyway, so it's a moot point.
Right, okay. Elizabeth, do you want to have...
I don't think the problem is the cost of it. I think the problem is the access to it. Like, if I get my genome sequenced, there is no national-wide database that everyone can use to share the data. So I could be really, really good for this treatment, but then you have to first email my GP, and then the GP has to send me a letter, and then I have to sign my consent, and then send that back, and then that can get emailed over there. Like, if they actually developed a proper national health database, that would be the way forward for it.
Yeah, I think it's a perfect point. I think it's a kind of chicken or the egg problem where until we're sequencing lots of people, we don't have the evidence to suggest that it's cost effective. But until we have the infrastructure in place, it's very hard to prove that. Can we sequence 100,000 people and better detect rare disease? We know that is possible now from the 100,000 Genomes Project, but that's taken 5 years, and it's only diagnostics of rare disease. It doesn't answer any of the other questions. So I think that's the hard part about it. We have to build international infrastructure to share.
Right, we've got some questions here.
Well, so my issue is rather storage, because storing this data is an immense problem, and not only storing the data but corrupting the data. So that is also a secondary problem that you have. So that means that you're going to have a backup on a backup, and which probably is going to require another backup. So I think the biggest problem, which is very rarely discussed, is actually storage. Because yes, we can look at the first generation. How about the second generation, then the third generation, then the fourth generation? I mean, obviously we're gonna probably take this as it comes, but storing the data is by far the biggest problem we have.
Mikey's got some question here.
Well, I think in a way we're gradually moving to this situation where data itself is a kind of currency, that just knowing data. Come on, have a sit there. Just knowing data.
Lovely, comfortable seat there.
Is actually the money itself. Like in the end, like when you got things like blockchain, that is the sort of the way that data actually becomes, the actual data itself is the currency, and I think the value of having the data will pay for it. In the end, however much data you've got, whether it's data, I mean, not just genetic data, but any kind of data.
Right, so let me just introduce the new people to the table. What's your name?
It's Michael.
Michael, welcome to Talkaoke. We're just talking about whatever we want to talk about, which at the moment is genomic data. What's your name?
Santa.
Santa.
Yeah.
Yeah, welcome to Talkaoke table. You can talk whatever we like about. So we're talking about storage of data, of your genomic data. And we asked everyone before, if you had a child, would you get their genome sequenced? You can say yes, or you can say no, or you can say I don't know. You can add conditions. Yeah. You think? Not sure?
Not sure. I would have to think and discuss with my husband.
Fair enough. What about you, Michael?
So the question was, if
you had a child tomorrow, a newborn, would you get their genome sequence if it was possible?
I'm not sure.
Yeah,
I don't know.
sure?
No.
No, you wouldn't?
Probably not. Not yet.
Why not?
I wouldn't see the real value yet in
The value.
that.
We've had different opinions around the table.
Yeah. So, for example, I've heard about the paper. I'm not coming from genomics background, so apologies if I'm a little bit too ignorant on that, but
that's fine.
I'm still learning about it. I've heard about a paper published by
Hold the mic. Hold the mic.
There's a paper published by a scientist from, I think, UCL or a university here in London, where a scientist with a big reputation in the field tested some of the most common providers of the tests, right? And apparently all of them provided very different results,
right?
Including what the lady actually did. She did also sequence her genome by herself. They did all the data analysis.
We were talking about this,
okay, there you go. So I think you see. So how can you trust? And you'll get the results, and there's so much bias probably, and so much still we need to learn about it. That I don't see a real value yet.
So there's value.
Yeah, exactly. I was going to say, because I said that I wouldn't have my child's genome sequenced tomorrow, but it's because of that uncertainty and that information we don't know yet. In a few decades' time, it's probably going to come quite quickly. If there's more certainty, then potentially. But I don't feel the need to introduce so much uncertainty without a real.
I like you were saying, why ruin a childhood? Well, it might be too much. Patrick, of course, says yes. I mean, it would be quite a boring bedside story if you had to read out your genome sequence to your child.
Sorry, the point I was going to make was that I'm actually my own worst enemy with that, is that I also understand that the only way to get rid of that uncertainty is to get more data, and therefore it's like a chicken and egg thing. So which kind of gets back into the data and storage and everything.
And storage of it. Patrick?
Yeah, I was just going to say, I've actually already been sequenced because we have a rare disorder in our family and it's not solved, but we've been part of a research project. So I think there's some risk to doing it. You find out something you don't want to know, but ultimately we won't improve until we increase the amount of data that we have.
And did you learn, actually doing it yourself, did you find it was different from what you expected? Did it kind of make you think of it in a different way when you actually had your own genome sequence?
Yeah, I mean, it was interesting how I actually found some of the more mundane applications like predicting traits and ancestry more interesting than I thought. I thought they would be uninteresting, but it's I suppose it's always interesting to learn something about yourself. I also, I don't know, the idea that you can do it once and potentially have a lifetime of new discoveries, because your genome essentially doesn't change, so you only have to do it once, and the algorithms and our understanding of how to interpret it continues to improve. So I think that's quite unique in biology. Normally you have to do your cholesterol every month to figure out what's going on. Most things change, but you can do it once. And I suppose there's great power and great responsibility to that.
And how are you storing it? Have you got it? How's it stored?
Yeah, I actually don't think storage is a big challenge. Here's why I will say so. You don't need, the whole genome's 100 gigabytes or whatever, which is huge, but you only actually need a VCF file, which is 1,000 times smaller. Also, even if you wanted to delete your 100 gigabyte file, it's all in your body, so if sequencing is cheap enough, then conceivably we could just sequence you the moment we need it, use it, and then throw it away. In the end result of sequencing is incredibly cheap. So I also think storage costs are going down all the time.
So two things. Number one is that in the healthcare system, we are required to store not only VCFs but more than that, which means we need to store loads of intermediary data that is redundant, which means that we have, if there are, let's say, 5 separate processes to that, one would be 100 gigs, another would be another 50 or 80 gigs, and it continues, right? So if depending on how that infrastructure looks like, and if that changes, then yes, you could address some of those problems. Now, I don't remember the other thing you said, but when I do remember it, I'll get back on it.
I was just going to say but even the hundreds of gigabytes you have to store in the healthcare system, you can put on magnetic tape. It's not like you're using it every day, right? It just needs to be there in case you need it. So the magnetic tape is so ridiculously cheap.
We're talking about generations, storing it over generations would be useful.
But you can use DNA-based storage to store it over generations. If you just take some saliva and extract the DNA, it'll last for 500 years, without much challenge.
Want to say something?
So on data storage again. So the thing there is that, so for example, when the CD revolution came, and then when after CDs came and we went to USBs, from an informatics perspective, at the point where we were using CDs and we went to literally using hard drives, the amount of CDs we have that if we took all the data that we had at that time, which was like at 2006 maybe, or 2008, if we took all the data we had in hard drives by then and just put them on CDs, we would have enough CDs to rebuild the entire New York, more or less. And that is something that I got from a talk before. But the point is that our current way of storing data is essentially solid state hard drives, or that's where we are at the moment, and that also requires that you have a data center. That also requires that you have a cooling system. That also requires that it needs to be in a remote space. The more data we store or create, the more we don't think about this problem, the more we'll have to create space to utilize it. And so right now, if you look at storage solutions, most companies, like big companies like Facebook, Google, they have their storage centers in cold countries that are quite remote, and that we can, they can essentially do that. But the question is if that would ever be a problem.
I mean, I think this is where genetics can kind of link to the other sciences, because I don't know what's going on, but I'm pretty sure I read somewhere that the quantum actual storage of data is coming on a fair bit now. So that's a good potential step of we could just be like, oh well, you made it really small, now we can throw it all in one disk. So I think there is the potential of this could be a branching topic of how we can link other sciences to genetics.
Well, what Patrick was saying, we all just have to spit into a tube and we put it through, we can store it for 500 years.
I got a thing on the quantum thing though. So the only problem with quantum, well, that will hopefully get solved at some point, but the main problem with quantum computers or quantum mechanics in general is obviously the Schrodinger's cat situation, right? If you look at it, it's not there or whatever. But the point when it comes to quantum computers, if we talk about quantum storage, then the equivalent to the Schrodinger's cat, which is exactly what it is that the system would have to be entirely isolated from everything, which means that you walk. This is why the storage is a bit difficult. But if you look at quantum computers right now, when you perform quantum calculations, then if you perform a test and you perform it 100,000 times, that should come up with a 50-50 chance. It generally comes up with a bias, and that is generally only because that we haven't, at this point at least, been able to perfectly isolate the quantum computer itself. Right. So that's talking about leaving a room by itself. But if someone would walk into the room, that data would even be skewed much higher. So to store data, when we think about the integrity of our data, then we're talking about something completely different. So it's probably quite far away, but I do like your point.
We're thinking far ahead here, the quantum world of storage, but it could happen, right? I think we might have to wrap up soon.
Yeah, that may be time for final thoughts, but I just want to say these huge data companies like Google and Facebook, they're spending so much money on storing this data because they know it's incredibly valuable. That's their business. So obviously there's a point in having the data. Yeah. And if there was, in a way, the more we can use genomic data, the more money we're going to spend on storing it.
Yeah, I think that's actually a really great summary, because I feel that the problem is at application and understanding, not at storage. And as we understand more and can apply it to new things, the value will increase. And maybe the problem right now is that the value doesn't justify the storage. But if we can get more out of it, you only have to sequence once. You could potentially do thousands of different disease predictions and other sorts of things. So I think it's maybe value to storage ratio.
Yeah, right. I think we're going to have to wrap up now, so we're going to have final thoughts. Well, we've done Patrick's done. Santa, what's your final thought? Have you decided yet?
No, I think I would I wouldn't sequence it because I don't have any diseases running in the family. But I would sequence because I would like to analyze his genome.
All right, for scientific reasons.
I mean, you might not know that you've got the perfect genes for fencing or something like that, but the genomic data could kind of also give career recommendations or something like that.
Final, sorry, I'll totally ignore that. Right, Elizabeth, what's your final thought of the evening?
I think that genetics is the future. Like, I think as soon as people like get that better understanding and the education system actually develops so that more people understand it, I think that's where
Genetics is the future.
Genetics is the future.
Okay. Isabel?
There was just one thought about survival of the fittest. If like the people that are stupid enough to pay to get their genome sequenced 23andMe, I mean, we've already given a lot of our own personal data away with social media, with Google, Apple, probably even our bank details and our credit card activities. So I don't think any of us are immune, and it's just genetic data is the next step in that. So.
Next stage.
So on that note, I mean, that happened essentially because there was an unregulated market and people took advantage of it, and to be honest, if you want my honest opinion, what Facebook has done, it's not necessarily that wrong. They were just clever in utilizing data that already existed, but it was unregulated and it went to a completely different level, which we couldn't regulate at the moment, and now we're stuck with this problem. So the same thing could obviously happen with sequencing data.
Right.
So I'm going to leave it at that, because otherwise I'll start something new like him.
My main concluding remarks is this has been the weirdest thing I've ever been a part of, so
right,
I appreciate it. Thank you.
Right, thank you. We are... So this has been Talkaoke. This has been the Festival of Genomics. Mikey wants to say something. Do you?
I want a final thought as well.
You've had a final thought.
No, that was just a comment.
Sorry.
My final thought is it's not just about illnesses and disease prevention and cures. I think there's way more to genomics than the medical side, and I think that's also exciting.
Yeah. Okay. The future is good. Talkaoke is bizarre and strange. I hope you've enjoyed it though, all the same. And let's talk to each other. Thank you very much.
Hope you have a good day tomorrow. We'll be back here tomorrow. Yeah, we're here all day tomorrow. So if there's anything you think of saying that you didn't say today, we're always here tomorrow to listen to whatever you got to say. Thanks everyone for taking part. And then big thanks to Dave. He happens to be a scientist on the side as well.